We're going to take a look at our worksheet that we had for homework last night based on friction. We've been working on friction for the last couple of days, and we're going to have ourselves a little quiz on friction tomorrow. So we want to be setting ourselves up nicely for that quiz tomorrow. Questions we want to do today, questions 4 and 5. Okay, good questions to pick here because question 5 is going to be, it's remarkably like the quiz question that you're going to have tomorrow, actually. Question number 5 is. Number 4 is harder than what you'd see on a quiz. Okay. Once we do it, it's actually not so bad. But for you guys to do it yourselves, it's a bit of a challenge question here. It says a hockey puck is hit on a frozen lake and starts moving with a velocity of 12 meters per second. 5 seconds later, the velocity of the puck is 6 meters per second. What's the coefficient of friction between the puck and the ice? Firstly, what kind of friction are we dealing with here between the puck and the ice? This could be dynamic or kinetic friction. Sometimes we like to call it sliding friction. Okay, that's a nice little reminder to us what kind of friction we have, right? If it's sliding along the ice, then it's kinetic or dynamic friction. All right, we know what VI is here. It's 12 meters per second. We know what VF is. It's 6 meters per second. And we know that my time interval here is 5.0 seconds. We want to find this coefficient of kinetic friction. So let's write down my kinetic friction equation here. Let's say Kf is equal to mu times the normal force. And we're solving for mu. But what's the value of FKF? We don't know. We don't know what FKF is. Do we know what Fn is, the normal force is? Well, we don't really know what the normal force is. Look, we know what FKF is mu times m times g, but we can't do that, right? We can't say mu times m times g because then we're just going to be going around in circles since we already used that equation, right? Just the rearranged form of it. We know that the normal force is mg. What other equation might I be able to use to describe the force of friction? The net force. There's only one force acting here besides friction, besides gravity and the normal force, and they cancel. So if there's only one force acting here, then we can say that it's the net force. And the net force is m times a. We're going to put absolute value signs around it because we're dropping signs here, right? Now, the last class I said, what do you do at this point? And somebody said, actually, I'll ask you what you guys did here. How many people got the answer, or at least think they got the answer? Okay, Simon, what'd you do? Yeah, that's what I was thinking the whole way through. That's what I was thinking. How many other people did that? Cancel out the mass? Okay, good. Anybody do anything different? Yeah. Oh, you see, you just made up a number for? Yeah, no, that's right. Yeah, because it cancels out, you actually can make it whatever you want. But somebody in the other class actually thought, I thought this was kind of smart. So what'd you do? And she said, I looked up the mass of a hockey puck. It's 0.160 kilograms, and she put in 0.160 kilograms, and it works. But it also works if you put in 1 kilograms or 68,212 kilograms, as long as it's the same mass on the top and the bottom, right? Now, what's the acceleration? What's the acceleration? Probably use delta V over delta T for this. Delta V is 6 minus 12. T is 5 seconds. It gives me an acceleration of negative 1.2 meters per second squared. But because I'm plugging in absolute values, we're just going to make it 1.2 over 9.81. And when I do that, I think I end up getting, I think it's 0.12, wasn't it? Yeah, 0.12. No units, because the units end up canceling, right? How many people ended up getting that, 0.12? Good. It's a tough question. Okay, it wouldn't be so bad now, but for you guys to see that last night, that's a tough question. Well, now they know the answer and the method, right? Now, I mean, that becomes a higher level, it's a higher level thinking question when you see it last night. Now it becomes not such a higher level thinking question because you don't have to think about it, you just have to remember it now, right? All right, question number 5. This is the one that we want to focus on because this is the one that's going to look a lot like your quiz question tomorrow. 100-kilogram object is at rest on a horizontal surface. There's a coefficient of static friction of 0.6, a coefficient of dynamic or kinetic friction of 0.45. We apply a force of 400 newtons. Does it move? What's the force of friction? What about 650? How much force do we need to apply to get it moving? Hey, let me ask you this one first of all. What relevance is the 5 seconds? There's no relevance. It makes no difference in the world. Force is not cumulative. So if an object requires 500 newtons to get it moving, then it requires 500 newtons to get it moving. Applying 400 newtons for 5 seconds or 5 minutes isn't going to help. If you need 500, you need 500. The time's irrelevant. So I'm just going to scratch that out to make it a little bit simpler for me here. Now, when I look at question A, I apply a force of 400 newtons. What's the force of friction? I got to know what kind of friction I have. In all the other questions so far, I've known whether it's static or kinetic. In this one, I don't. To find out what kind of friction you have, you got to know whether it moves or not. Does it move in question A when I apply a force of 400 newtons? How do I know? What do I got to do to find out if it moves and therefore whether or not I have kinetic or static friction? Yeah. Okay. Yeah, let's get FSF max. Now, if 400 newtons is bigger than FSF max, then it moves. If 400 newtons is smaller than, it doesn't move. If it's bigger, I have kinetic friction. If it's smaller, I have static friction. FSF max is going to be equal to mu times the normal force. And mu, coefficient of static friction, is 0.60 times 100 times 9.81. When we do that, FSF max works out to be 588.6 newtons. So that's how much friction will respond. I mean, think about this, right? We said static friction pushes as hard as it needs to counter my applied force, unless we exceed the maximum possible force. The maximum possible force is 588. That means that friction can push all the way up to 588 to counter my force. I push with 400. Does it move? No, because I haven't exceeded the maximum possible value. All right, if it hasn't moved, then I've got static friction here. What's the value of static friction? It's equal to however hard I push, right? Which is 400 newtons. So I'm going to say FSF, force of static friction, is 400 newtons. Remember, actually, it should be 4. You know what? Actually, I was going to say 4.0 times 10 to the 2. It's not. It's 400. Okay, why is it 400? I didn't actually do a calculation here, did I? I just copied down the number that I have here. The only number that I used is 400. So it would be 3 digits. Now, if you had made that 2 digits because you used 2 digits over here, okay, I wouldn't have zinged you for that because that's a tricky one. But it is 3 digits because that final answer relies only on the 400 newtons. I push with 400, it doesn't move, therefore friction is going to just be static and it's going to be 400. Push with 650, does it move now? Yeah, it does, because now I've exceeded the maximum possible force. So what kind of friction do I have now that it's moving? Kinetic friction. And what's the value of kinetic friction? 650, 400, 588.6. Yeah, we got to find it, don't we? We're going to say FKF is equal to mu times the normal force. Again, except this time it's kinetic friction. Mu is 0.45 times 100 times 9.81. And that's going to give us a value for kinetic friction of, for this one is 2 digits, 4.4 times 10 to the 2 newtons. What if I pushed with 800? What would friction be? Kinetic, 4.4 times 10 to the 2. What if I pushed with 200? What would friction be? 200, because it would be static. What if I pushed with 587? What would it be? 587 because it doesn't move. What if I pushed with 590? What would it be? 4.4 times 10 to the 2, and it would be kinetic friction. Yep. Okay, good question. Why did I make this one 3 digits? I made it. Well, no, I used 2 numbers to find the force of kinetic friction. 3 numbers actually. Mass, which is 3 digits. G, which is 9.81. But I also used the coefficient of kinetic friction, which is 0.45. And that's only 2 digits. So up here, I didn't use the coefficient. I did over here, but that number actually doesn't come into play here. Didn't use any numbers other than the 400 to get this. So it's going to be 400. But this one, because I used a 2-digit coefficient of friction, then I have to count it as 2 digits. Yeah, that's 400 newtons. Yeah, yeah, 400. Good. What about C? How much applied force is required to get the object moving in the first place? More than 588.6. We'd say it would be 2 digits, because to calculate FSF max, I had to use that coefficient, right? So 2 digits, I would say 5.9 times 10 to the 2 newtons is what I have to exceed. Okay, I didn't exceed that in question A, so it's static friction. It's just however hard I push. I did exceed it in question B, so therefore it's kinetic friction, and I got to figure out the value. Yep. Yes. Yes. Because that number came from this calculation, and in this calculation should have been by rights 5.9 times 10 to the 2, as opposed to 588.6 because of 6.6. Good. No, no, not at all. No. You have to show all of your work. But if you've already shown it for a previous question, then that's fine. Just like some of those graphing questions that we saw back in Unit 1, where, you know, we've already done something, but, like one of the questions was get the displacement from the graph, right? So we had to show our work to get the displacement from the graph. And then another question was find the average velocity. Well, that was displacement over time, but we didn't have to show the displacement again, right? We just used the number that we had from the previous question. All right. All right. If you think you're good at that, you're pretty much ready for tomorrow's quiz. But let's do a little practice quiz first here. This one doesn't count, but pretend that it does. Put yourself in the frame of mind of a quiz tomorrow and see what you can do on this, okay? So our question says a 10-kilogram object is at rest on a surface that has a coefficient of static friction of 0.95 and dynamic friction or kinetic friction, which is 0.65. Listen, we know that static friction, the coefficient of static friction will always be bigger than the coefficient of kinetic friction. So this fits with our experience, right? Static friction bigger than kinetic friction. We want to know what the force of friction is if we apply 50 newtons or if we apply 300 newtons. Let's see here. How do we go about doing this? Well, we want to find a force of friction. We got to know what type of friction we're dealing with, right? Do we know what kind of friction we're dealing with yet in question A? No, we don't. We don't know what kind we're dealing with in question B either. So we got to figure it out. How do you figure out what kind of friction you're dealing with? How do we know whether we've got static or kinetic friction? You got to find FSF max. Get the maximum value. If you exceed that, then it moves, it's kinetic. If you don't exceed it, then it doesn't move and it's static friction. FSF max is mu times the normal force, which is 0.95 times 10 times 9.81. And what do we get for that value of FSF max, the maximum value of static friction? Cameron, you got that? 195. which by rights we should round to 94 newtons, right? Okay, that's not my answer to question A though, right? That's just the maximum possible value of static friction. Now, ask yourself this question. If the maximum possible static friction is 90, is there a mistake? Sure, 93. Yeah. Thank you. Ask yourself this question, guys. If the maximum value is 93, but you apply a force of 50, does it move? No. I got to apply a force of at least 93 to get it moving. So it doesn't move. Therefore, question A, I've got what kind of friction? Static friction. Good. I like having static friction because even though it's a pain in the butt force, it's easy to figure it out, what its value is. If I have static friction, then static friction will always be what value? However hard I push. Right? How hard do I push there, Nick? Okay, so what's the force of static friction? 50 newtons. Now, what if I apply 300 newtons? Does it move now? Yeah, because I just exceeded the maximum possible value of static friction. It moves. So what kind of friction do I have now? Kinetic friction. So let's get its value, because we don't know it yet, right? It's mu kinetic times the normal force. And the coefficient of kinetic friction that's given to me in the question is 0.65 times 10 times 9.81. What does that work out to be? 64 newtons. There we go. Notice kinetic friction is not smaller than static friction. It's bigger. Didn't we say that static friction is always bigger than kinetic? Yeah, no, we didn't say that static is bigger than kinetic. We said the maximum static is bigger than kinetic, almost always. All right, so what if I applied a force? Now that we have all this information on the board, we can answer a few more questions. What if I applied a force of 20 newtons? What kind of friction would we have? Static, and what would its value be? 20. What if I applied a force of 91 newtons? What kind of friction would I have? Static, what would its value be? 91. What if I applied a force of 95 newtons? What kind of friction would I have? Kinetic, and what would its value be? 64. What if I applied a force of 1,000 newtons? What kind of friction would it be? Kinetic, and what would its value be? 64. What if I applied a force of 10,000 newtons? Kinetic, and it would be 64. So static friction is always however hard you're pushing until the maximum possible value. Kinetic friction is always just going to be the same value. You got to find its value based on the coefficient. Yep. Yes. If I understood the question correct, at least. Are we going to relate how hard I push to the acceleration of the object with friction in the mix? Yeah, eventually we will. Yeah, we're going to get towards that a little bit later today. Not that specifically, but towards that later on. Basically, what I think Cameron means here, guys, is that, I mean, if I apply a force of 50 newtons, it doesn't move, then there is no acceleration. So that's easy, right? But if I apply a force of 300 and friction is acting back at 64, because that's what would happen, right? Then what's the acceleration? Yeah, we will deal with that. All right. Got a few questions for homework here, 1 to 6 and 10 on page 190. The good news is we're going to do a lab tomorrow after our quiz. And that means that we're not going to have an opportunity to check this homework tomorrow. So this will be due for Friday. Okay, this homework will be due for Friday. There's also going to be 2 more questions later on that's going to be due on Friday as well. So you probably don't want to leave it all till Thursday night, but you have 2 nights to do it. Page 190, number 1 to 6 and 10.